Sass Class with Amanda. Hey! In this video we're discussing scatterplots, and we want to describe a scatterplot. We created one in another video dealing with the example of the bigger they are, the harder they fall, where we had 5 objects. We weighed each of them and have their measurements in kilograms, and we also determined the force with which they hit the Earth's surface. Anytime we have a scatter plot, which is a plot of 2 quantitative variables, and its purpose is for us to determine what the relationship is between these 2 variables. So anytime we have a graph that looks like this, we want to describe exactly what we see. We want to describe direction, form, strength, and outliers, and we'll go over real quick what each of these things are. So direction is the overall pattern. Overall pattern. Right? And the form is, it's the approximate functional form. And what that means is it could take on a quadratic form, it could take on a linear form, exponential, etc. So approximate functional form, where the examples I gave were quadratic, linear, exponential, etc. And if you don't remember what these functions look like, you should really go back and review quadratics and exponentials from algebra. Alright, the third thing you want to describe is something called strength, and this is how closely the points follow that form. How closely the points follow the form. Alright, and in general you can say weakly, weak, you can say strong, and you can say fair. In one of our other videos we'll talk about how to measure strength for linear forms. Okay. Outliers are just like the deviations that we would describe in histograms and stem plots. And this is just an individual that falls outside the overall pattern. So whatever pattern you decide the data has, which would be your answer to just direction, you might find individuals that fall outside that pattern. Okay, so we're going to just take the graph from our other video, and you describe these 4 things. Okay, so direction, what is its overall pattern? So we see that it sort of moves upward, right? Each data point increases along the x-axis and the y-axis, okay? So as weight increases, so does force. So that would be our answer for direction. Okay, so as weight increases, and I'm just going to use an upward arrow, force also increases. Okay, that describes our direction. Now we want to talk about form. So what function does it look like this data follows? Well, with the way I've drawn this, it could be a loose parabola, right? It could also be linear, okay? So what we want to do is probably figure out which one does it fit the best, okay? So let's sort of sketch a line here that goes through some of the points. Okay, so that would be what a line looks like, approximate line. And if we had a quadratic, it might look like this. Okay, so which one do the points follow the best? Well, based on the way I've drawn it, it looks like a linear function fits these points the best, okay? Strength. So how strong is this relationship, this linear relationship? Well, we have 1, 2, 3, 4 points that almost fit exactly on the line. So based on the way I've drawn it, it does look like those 4 points are on the line, but most likely they're a little bit off, depending on the scale. So strength, we're going to say, is strong. All right, and do we have any outliers? Well, this is the one data point right here that doesn't lie on the line or is very close to the line. So we could say that that point is an outlier, but it's not a significant enough distance from this line to say that it is, I think, anyway. In another video, we'll talk about residuals, and we'll use those residuals to really measure whether something is an outlier. So we're going to say no. Okay. So when we're describing direction, we really want to use the same vocabulary that statisticians use, so that they understand what we're saying when we say it. So there are 2 phrases to describe direction. There's a positive association and a negative association. And a positive association occurs when, as one variable increases, the other does as well. So when one variable increases, the other does as well. Alright, and that's what we have. We have a positive association for our example with the objects, right? Because this definition is exactly what we described for our direction. Alright, now a negative association is different. Okay, so when one variable increases, the other decreases. So if we're thinking about linear forms, then notice that in the previous example, we had a positive slope. Okay, so you can think of this as a positive slope. And then a negative association, you can think of that as a negative slope. Okay, so this is just to refer to things you might already be familiar with from your algebra studies. So this is a rather short video. Everything that we need to summarize is on the same page that we just took notes on. So what we learned is how to describe a scatter plot. We describe it with direction, form, strength, and outliers. Okay. Here are 2 formal ways to describe direction with positive association and negative association. And this really only works if the form is linear. Okay. And we described direction, form, strength, and outliers using an example from an earlier video.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 110. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife, the implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.